Hi guys, sticking with adding and subtracting fractions, we're going to go and have a look at a slight extension of that. We're now looking at adding and subtracting mixed numbers, which include fractions. And a lot of the skills we've learned previously are going to help us with this. There is just a slight change, so let's get into the examples and I'll show you what I'm talking about. Right, let's look at the mixed numbers, adding mixed numbers. So there are a number of different methods to use here. I prefer to split the addition into two steps where we deal with the whole numbers on the left hand side and the fractions on the right hand side, and in the end we just bring them all together. And to do that I would normally just split my jotter or my screen, and for the time being what we'll do is we'll just split the screen so that I'm dealing purely with the whole numbers on the left hand side and the fractions on the right hand side. And when we do the fractions, it's the same as we've always done. So first of all, the easiest part of this, we've got 5 plus 4, and these numbers come directly from the question here. 5 just drops down and the 4 just drops down. Okay, so 5 add 4 is 9. Now we'll leave that sitting there because we're going to bring the fractions over in a second. Next step, what we would do is we need to take these fractions and move them over here. Okay, so we're effectively just dropping the fractions into this area. And what we have is we have 1/5 plus 1/3. Now, based on the last video's work we've done, what we need to do there is, it's quite clear, we need to make common denominators to allow us to add these fractions. So let's make the common denominator first. The 5 times the 3. So these two numbers here, 5 times 3 is going to give us our common denominators to go in here. So 5 times 3 is 15. Now, as we've done in the past, if I changed the 5 to 15, then that's because I multiplied by 3, and then therefore I must multiply the 1 by 3. So 1 times 3 is 3. Equally, 3 multiplies by 5. So the 1 at the top here has to multiply by 5, and then we have 5. What that gives us is a final answer of 3 plus 5 is 8 over 15. Now that 8 over 15 can just come straight back up here and we place it next to the 9. So 9 and 8/15. Okay, that's the first question done, and there's a lot of writing in there. We'll try and not do as much with the arrows next time. We won't have the steps in there, so it might be a little bit clearer. So we'll move on to question 2. Okay, question 2. Start again. We've got our whole numbers. This time it's a subtraction. So our whole numbers here are 3 and 1. So we have 3 take away 1 equals 2. And we'll leave that there for the time being while we deal with moving the fractions. And like we've seen before, the 4 over 5 and the 2 over 7 are going to shift over to the right hand side. Okay, so as those numbers come over to the right hand side, what we need to remember is it's not just the fraction that's going to move over, it's the subtract. Okay, this is a take away this time. So we've got 4 over 5, take away 2 over 7. So the first thing we would do is we just create our common denominator. Okay, I've jumped a little bit ahead there and we're picking 35. Now 35 just comes straight from the fact that we've got 5 and 7. We take those two numbers, multiply them together to get our common denominator. That means that as we go through this process, it should be a little bit clearer to see what's happening to each fraction. Okay, so on the left-hand side here, the 5 changes to 35. So 5 times 7 is 35. So that means we must do 4 times 7 also. That 4 times 7 will give us 28. Equally, on the right-hand side, the 7 has changed to 35, and what we did to do 7 to 35 was 7 times 5, so we must do 2 times 5 at the top, and that gives us our 10. We then just deal with fractions. Now that we've got our common denominator, 28 plus 10 is 38 over 35, and what you'll see is that that's another improper fraction. So top-heavy fraction, that means we have one whole number with 3 left over, so 1 3/35. Okay, now this adds a little extra layer to things when we're going to be moving this over. I know I'd said previously we're going to now move that answer over here. And what that gives us is it gives us 2 plus 1 3/35. And hopefully you would assume we take our whole numbers and we add like we have done before. 2 plus 1 is 3, and we're just left with 3 3/35. And that's us done. Okay, so we should be a lot more familiar now with the process. I'm going to speed things up a little. What we've got now is we have another subtraction, but with some larger numbers. So we start off with our whole numbers. 20 take away 15. So 20 take away 15 just gives us 5. We're going to shift these fractions over. So 2 over 7 take away 3 over 4. Okay, now this is a slightly special case, and you'll see that now when we start to create the equivalent fractions. Okay, the common denominator here, 7 times 4, is just going to be 28 on both of these fractions. And when we go through our process of what's happened, how did we change the 7 to 28? So 7 to 28 was times by 4. So 2 times 4 will give us our 8. Okay, equally, the 4 to 28 is times by 7. So 3 times 7 gives us 21. And what you see here is we now have 8 over 28 take away 21 over 28, and that would lead us into negative fractions. Now, negative fractions is something we can discuss, and there's occasions where people find that a little bit easier, but I'm going to stick to showing a way that we can maintain the positive fraction. So 8 take away 21 is clearly something that we can't do. So what we've got here is we've got a problem. We've got a shortage of 28ths. So what we need to do, just like you would have done when you were younger with subtractions, sometimes you have to borrow. Okay, so the only place we've got left to borrow from is over here with our whole numbers. We've got 5 whole numbers. Now we don't need to borrow that whole 5 whole numbers. We just need some additional 28ths, and this is where a little side note may be useful. Okay, so to borrow 28ths, it is useful for us to borrow one whole number and to make that 4. Okay, that one whole number, if we pop it over here, is the same as 28 over 28. Okay, any single whole number is any fraction that's the same on the top and the bottom. So if we borrowed effectively that 1, we're borrowing that and we're going to place it in here. Okay, so the best place for us to do that would be to squeeze it at the front of the 8. But if we can talk through that, what we've got is we've got the 8 28ths plus the 28 28ths that we've added from the borrowing step. And now take away 21 28ths. So there's a multitude of different ways you can do that. We can do 28 plus 8 gives us our 36 over 28, and then subtract the 21. Some of you might be able to do that all in one step, and therefore our final answer is 36 take away 21. So we have 15 over 28. Okay, and like we've done before, we would just simply take that 15 and move it over here. And in the end, that's going to give us our 4 whole numbers and our 15 over 28. Slightly more complex because of the borrowing step, and I would anticipate that's the part that people will find difficult. But if we have any additional problems, then you can make contact on Google Classroom, and if I need to, I can do a follow-up example.